In this try it exercise, we're given a function, a radical function in this case, and we're asked to find the domain, we're asked to graph it, and then based on the graph to give its range. And we'll give those in interval notation as well. So we're given f of x equals the square root of x plus 2. It's an even index. When we have an even index on a radical, we know what's under the radical has to be greater than or equal to 0. So first, to find its domain, we have x plus 2 is greater than or equal to 0. And subtracting 2 from both sides, we get x is greater than or equal to negative 2. And in interval notation, that's inclusive. It includes the equal sign, so that's going to be a square bracket to indicate that it includes 2, and then it goes on for infinity, or it goes on infinitely. So we're asked to graph. We'll plot some points. We know the basic shape since it is a square root function. And we know it has to be, that x has to be greater than or equal to negative 2. So we'll start with, let's just start with negative 2. When x equals negative 2 plus 2 is 0, and the square root of 0 is 0. So we'll plot that point first. Let's make sure we label our axes, and we'll go to negative 2, 0. Now let's go ahead and skip 1 and go to 0. F of 0, 0 plus 2 is 2, and that would be the square root of 2. Now the square root of 2 we can approximate for graphing purposes at least, and that's going to be approximately 1.41. So we go to 0, 1.41, which is going to be right about in here. And now at 1, we'd have the square root of 3. Let's go to 2. F of 2 is the square root of 2 plus 2, which is the square root of 4, which equals 2. So we go to 2 and up 2. And as we increase, let's look for another perfect square, one more point for good measure. If x were 7, we'd have 7 plus 2 is 9, and the square root of 9 is 3. So we go to 7, 1, 2, 3, 4, 5, 6, 7, up 3. And that gives us our general shape. Note that there's nothing else that limits this function. So that's going to be its basic shape. And the arrow indicates that it goes on infinitely. Now, if we'll look at where it's restricted in the domain, it starts at negative 2. So the range is also going to be restricted on the left-hand end. It's going to start at where that point starts, which is at 0. So we're going to have y is greater than or equal to 0. It doesn't appear that it's going to approach anything either. The larger number you put in, the larger output you're going to get. So it just keeps on getting bigger infinitely. So y is greater than or equal to 0. And in interval notation, that would be range. It includes 0 because at 0, x is 2, y equals 0. And it also goes on infinitely. So the range is going to be 0 inclusive to infinity.